Okay, so design patterns. Design patterns are solutions to common repeating problems in software design. There are 23 patterns under 3 categories, the categories being creational, structural, and behavioral. Creational design patterns are different ways to create objects. And this is like the list of the different creational design patterns.
Now, would you say that would be a way to create objects dynamically, like during when the program is running, right?
Yeah.
Right. So that's something that you guys maybe not have done yet. Is you're always coding out an object or coding out a class yourself. Some of the design patterns are a way to create a class during runtime, which is a really cool concept. But I'll get to you.
Yeah. So structural are relationships among objects. And behavioral is interactions between objects. I'm not going to go through all the design patterns, but I do have a good link that goes through a lot of them that I'll share in Slack after the lesson. So why you should learn design patterns and the uses of it is it makes communication between developers easier. If you run into a problem, there's probably a design pattern you could use no matter what language you're using or framework. Like I said, it translates to many applications and programs, and it makes it easier to learn new frameworks faster. So today I'm just going to go over the strategy pattern, which is a behavior pattern. So the strategy pattern, you define a family of algorithms, encapsulating each and making them interchangeable. And it lets the algorithm vary from each client independently. The uses of the strategy pattern is it makes it so there's a less list of conditionals. It avoids duplicate code. It keeps class changes from forcing other changes. You can hide code from the users, and the one flaw of it is that it increases the number of objects and classes.
I'll add a little bit on that. So one thing to keep in mind is like the term con is kind of a difficult item. It's really what the cost is on all of these things. So it's one of those terms that I like to kind of clarify for people. It's hard to say pros versus cons. It's benefits versus cost. What do we get and what does it cost us to get these benefits? In this case, yeah, we're increasing the number of objects, which increase our memory and our RAM and stuff, but we're getting these benefits out of it. Yeah, I love that idea that reduce the long list conditions. How many people have had the never ending if, else, if, else, if, else, if, else, if annoyance, right? Or the giant switch case statements and stuff. So that's a good idea to use this. Some people have always asked me when they create those long case statements or if statements like, how can I fix this? Like, there's a way, there's a refactor for you. Strategy pattern. Good call. Go use this one. I like this one. Go for it.
Yep. So I feel like we did something similar to strategy pattern in class, like the bank system we did was pretty similar to what I'm going to do. And so let's get to it, I guess. So I'm just gonna start by making an interface.
Let me,
so this is the code along part. People go ahead and make a new project.
Yeah, I'll give it a minute.
Well, they're getting ready. I'll let you guys know again what the aftermath of this lesson is. So again, Emilio's giving you the understanding what design patterns are. He's going to showcase one of them. You mentioned a couple. what I will say is that it's your job though to go out and find and kind of learn about the use cases. So no one's expecting you to know exactly how to implement every single design pattern off the top of your head. That would be insane and people would find you as a genius. Now, if you can, go for it. But what they really want to know is that you know of the design patterns and you know about them and what a use case would be so that you know them well enough that if you hear a problem, a design pattern might pop in your head like, you know what, I have an idea of a couple of patterns I might be able to use in this situation. Let me go double check them, make sure and see if any of them actually do fit. And then once you realize, yep, this one would fit this use case, now let me go figure out how do I actually implement this one. We have Google, companies know that, that's fine. What you're expected to do is just know about design patterns and know of a couple of the design patterns and their use case off the top of your head. That's all you're expected to know. Not how to implement them necessarily, but to know about them, a use case, you can easily search for the implementation online.
All right, I'm ready now. I don't know if anyone else needs more
All
time.
right. I was also thinking of maybe expanding on like another one for Monday.
Depends how quick David is. So if you guys can both do a lesson on Monday, that'd be awesome. The more stuff you want to teach each other, go for it. I'm never going to stop you guys. You guys can always have more little in-person lessons. They're great for that stuff. So go for it.
Okay. So since it's going to be a bank, I'm planning on just making a deposit interface and having a checking account and a saving account and implementing that. So it's just going to be a simple public void deposit money and int amount. Make a checking account. Which implements deposit. It's going to implement the method from deposit. It's going to keep it really simple and give it a value into balance for what the balance is on the checking account. And then do S out. Deposited amount plus to checking account. Current balance is, can't see my screen. Plus integer dot sum of balance and amount. So now I'm going to make a saving account, which is going to be pretty identical to the checking account.
I am a little curious, actually. Is there a reason why you used integer.sum instead of just doing balance plus amount? Is there any benefits to that item? I'm sure that someone here is probably like, why don't you do that instead of just adding the two together?
This is preference for me.
Okay. There could be a benefit to it. That's definitely to check on. There could be a benefit, like it might protect against like negative values and stuff like that, maybe, or handle negative values correctly, possibly. But something definitely to check into. I'd be curious to know if that does, because that would be interesting to find out if there's any benefit to that. Otherwise, why would they have the method? It's not. It's almost unnecessary, right?
Yeah.
Cool. Go ahead.
So this is going to be pretty identical to the checking account. Oops, I put.
You wrote checking.
Yeah.
I think you may have forgot to put the constructor in checking account too. I
Yeah,
could be wrong.
I
but-
did.
Uh,
Thank you. I'm just gonna copy and paste this line. Just switch it up a bit.
Don't forget, on that long line, you can do line returns where you see the pluses. So after the plus, you could actually move that item to another line if you want to make sure that line doesn't get too long on you.
Oh,
So
Yeah.
the white space is used by the developer, not by the program. Semicolons in the line of code.
okay. So under main, just gonna make a checking account equals checking account. And we're gonna give it a balance of 0. And then I make a savings account. And balance of 100. Actually, why?
Constructor.
All right. Okay. Save an account. And we're gonna deposit money. And we'll deposit 900. Then check an account. Deposit money. 200. Just gonna run the build. And there we have it. Really simple strategy pattern.
Lose you?
Yeah, that's pretty much it. Yeah.
Any questions, people?
It seems pretty
Good stuff.
straightforward.
Yeah, straightforward. The main focus of this item is making sure that this strategy pattern enforces, in an object-oriented sort of way, it's enforcing this method to be created in a certain way. So it helps to make sure that people don't forget it, and it makes it, yeah, as he said, behave a certain way for different objects and classes. So it's a very interesting pattern. But as you see, we have no if statements now. There's no if this is a savings account, if this is a checking account. We know that they all have the deposit, but there's no if statements anymore. So very good stuff. Cool thing.
So it's if you were going to do this the other way, you'd have to have a bunch of if statements. And just because you've eliminated the if statements is it because of the way you created is it the classes? and the
Well,
way-
one of the other reasons would also be a single class, just a bank account class, and then the deposit money method would have conditionals to check what type it is, and there would be more logic to have to decide, am I a savings account or am I a checking account? There'd be more ifs and conditionals, right? Would that be the way you'd say it, Emilio? Sorry, I jumped on that.
Is this kind of along the lines of dependency injection?
I don't
Yeah,
Don't be
I'm not
saying
sure.
something to make their heads explode, guy. Because you learn new stuff.
No, I'm just asking.
He's not doing Java in his internship, so this wouldn't be from that.
Yeah, it wouldn't be.
But,
from that. I just asked this because for my so what I'm showing Monday, I'm using a little bit of dependency injection, and I was just kind of, I really couldn't hear too well, but I was trying to follow. I was just asking that this kind of follows that, right? Not trying to be asking too many questions or anything. I'm just like, you know what I mean? I'm just kind of curious. Is that kind of like how it follows? I'm not trying to trip you up or anything.
unless Emilio says this, I'm actually not sure on this one. This is one of the ones I'd have to check on. I'm actually not sure if it
I
follows.
think it kind of looks like that's what it was reminding me of. I'm not sure.
I see what you're asking it, and I can see the similarity in why you're asking, but I actually don't know if it is. That's what I'm saying. Like,
Because I just heard Elaine's question. That's why I asked.
Like it might be. I don't think it is, but it might be. Again, based on what I understand of dependency injection, I can see why you're asking, but I feel like it's a no. I don't think it actually is dependency injecting because it's not dealing with dependencies technically, but I can't say for sure that I'm confident in that answer right now. I'd have to either double check on it or something that this would be something I would double check yourself too. Check on that and see. This would be something that you would want to research because it's something that I would have to research as well.
Wasn't trying to be that guy, guys. My bad.
No, this is the questions you should ask. These are good questions.
He was kidding. He was kidding.
No bad question.
I kid.
I kid.
No bad questions. All questions are welcome and all questions are good. Even if I don't know the answer, that just tells us that there's always more to learn.
More to learn.
And that just, and for anything, I actually enjoyed it if I ever asked the question that the teacher's like, I'm not sure, because that meant, okay, cool. I now know something that the teacher doesn't know. I'm going to go find out. So that actually excited me whenever I found out that I asked a question that the teacher didn't know. So at least my way of doing it. But no, like I said, design patterns overall are simple. They're meant to be simple to make your life as a developer easier. So if design patterns were complicated, they wouldn't be doing their job. The idea is that any design pattern you do should be simpler than doing it the non-design pattern way to get the same result. If you try to get the same result without the design pattern, you'd have to research and come up with your own way of doing the exact same thing. So that's one thing I do want to make sure is very clear. Some people are like, well, that seems way too simple.
So it's like a trade of it. I completely forgot what the hell Emilio was teaching. But dependency injection is a design pattern. So this is kind of the same concept. Anybody wants to
this is the strategy design pattern though. This is not dependency injection design pattern. This is the strategy design pattern. So
okay.
Be aware, it's a different design pattern.
Okay, but all right. My bad, guys.
Yeah, all good.
I still have a question though.
Go for it.
Because I guess I'm trying to back out to like where, when you get to the point where you're sitting down and you're writing code and you say to yourself, this is really complicated. I want to do this more simply. Like, how do you get from, here's my problem. How do you recognize that this is what you're doing is not that effective or that efficient. And then you say to yourself, well, I'm going to look for a design pattern that will help me here. And then I find this, like, how do you how is that process? Is that just because you have to know in your head about that these things are there and then you start to put them together? Like,
No. You mind
say
me
no?
Something, Cliff?
You say no. Emilio, what would you say since you just researched the design patterns? This is your lesson. So what would you say about that? And then I'll answer. You can say you're unsure. That's fine.
Yeah, I'm unsure, but I think like in terms of like writing code, if you find yourself like repeating the lines and stuff like that, you're probably adding more than you have to.
Yes,
right.
Emilio, that's it. Things that are called code smells or a situation where you just feel like I'm not doing this right. You're going to start feeling those issues of like, you know what, there's got to be an easier way, or this feels gross, this feels ugly. And the more you learn about what type of code is bad and what type of practices, that's why we talk about solid principles. So as you guys are now Java developers, you might want to look into something called solid principles. You have the concept of clean code. We've talked about the 4 principles of Java. If you feel like you're ever violating one of those things, that should be the hint that there's got to be a better way or some sort of other system out there that you can look into. Now, what I will also say though, is the thing that can benefit you the most in any of these items, and whether or not you should be doing something a different way, is knowing these other ways. And that's what these design patterns are here for. These design patterns were created by previous developers who said, hey, there's some repetitive work we do. We constantly deal with this issue, with this problem. It's a problem that repeats and shows up all the time in the code we're writing. And so we found there's this common way of solving this problem that is efficient and effective. So we're gonna document it. Like, again, the reason why they could use it in design patterns is that it's a term also used in construction. And when you have construction people always building apartments or always building restaurants, there were certain patterns in a restaurant construction or an apartment construction that they realized this is a common pattern that restaurants must follow, or that apartments must follow, or warehouses must follow, or factories must follow. And so the construction people would build these design patterns as well of these are the ways, if you're going to build a restaurant, here's a good pattern on how you set up the kitchen and how you set up the cleaning area or the cooking area. This is a good pattern of where each, like all the ports and stuff should go and how the layout should be. Follow this and you'll have a solid kitchen area for a restaurant. You don't follow it, you're gonna have a restaurant kitchen that's probably gonna have to be remodeled at some point and redesigned. So that's what's kind of the idea here too, is that they found these patterns are efficient, they work well, and they provide good results for the problems in case. It is up to you, and that's why I said no one's expecting you to memorize the implementation of the design patterns, but it's good for you to go read at least once or twice, read the design pattern names, read the why you would use them and what the benefit of them is. So that way, as you're going through the code, as you're coding, and as you're kind of talking to yourself about the problem you're trying to solve, it might trigger in your brain, wait, this sounds familiar. I think there's a design pattern that solves this. Let me go double check. You need to have that experience in your head that'll help you to trigger those memories. But like I said, Amelia definitely pointed one major thing out there. You'll start feeling wrong if you're coding wrong, and there's a better way to do it. So repetition, code smells. If you're creating way too many objects, or you're having to do this overcomplicating, you're overcomplicating, and you're like, this is so difficult. Maybe there's an easier way. So you definitely want to check at that point. Good stuff. Any other questions?
He's not nasty, but he has the bit.
That is muting you.
All right, I just can't let this go. Because I'm looking at this thing. It's so bloody simple. And I know when we made the checking, like when you did the bank account before, I know this isn't a really big bank account, but and what's killing me, like the thing that doesn't make sense to me is, how do you know that you can write this checking thing in like 4 lines and it's going to work?
Well,
Go ahead, David.
Here's how it's going to happen. Like if you're a coder, right, when you first start out, you're going to start writing like super exorbitant, like huge lines of code. And then your boss is going to come by and like, all right, well, you do what you do to make it work. Mm-hmm. And once it's working, that's when your boss is going to come up to you and say, hey, I need you to refactor that code, make it smaller.
And your coworkers.
And your coworkers.
Who are going to do code reviews, and they're going to help teach you what you don't know yet.
Right. So, they're going to try to lead you down the path of like, okay, like for example, my old boss, I would write a function and I do it in 5 lines. He's like, all right, I did it in 2. I need you to do it in 2 also.
Mm-hmm.
I get it.
And that's how we would do that. But like patterns are more for like for example, this is a strategy pattern. There's another one called the singleton pattern. Yeah, and the reason why it's called a singleton pattern is because it makes sure that there's only one of that object ever in your application.
And remember instantiation, that concept of instantiation.
You can only instantiate it once. And if you want a new one, you have to kill the old one.
Mm-hmm. So it's not a abstract or not a static class. It's just a single instance class. Again, we talked about this. Time would be a really good example of that. There is an instance of time, but most of us share one instance. But it's still not something that can be talked about that has to be instantiated technically. It is something that is instantiated. There is a start to time. So that would be my example of the singleton.
Yeah, another good with the time example, like say for example, you decided to create an application for your students to take a test, right?
Yeah.
You only want one time clock to exist, because if more than one time clock exists, if they ever were able to hack it per se, right? They can say, well, you know, my time clock says I got 20 more seconds or another minute. You know?
Another hour.
Right,
Another
exactly.
hour.
So once you harden your application and you know that you only want one time clock for all of these instances of the test, then they can't attack it because it already exists and there's nothing you can do about it. And you'll notice if they do attack it, and let's say you do have a super smart guy that hacked it and you know that you started 2 hours ago and the time's still going, you know that one object was hacked. So you know that everybody cheated. So now you get everybody, you know, because it only exists once.
Yeah, and the last thing I'll say about it as well is I will remind you that when I created the bank account application with you guys, I did explain that what we're creating is not the best way of creating the bank account application. It's meant to use as examples for the items we talked about. Creating objects, instances, inheritance, all those aspects. It was more focused on teaching that, not creating a good bank account system.
So what I understand is you learn how to code a thing so it works.
Mm-hmm.
And then when you
start
get
there.
coding a thing that works, then people start saying to you that already know how to code, they start saying, yeah, that works. Now make it better. Refactor, refactor and understand and make it better. So it's like, it's you're constantly improving.
There's multiple things. Yeah, there's the coworkers. There's your own personal realization as you learn what good code looks like. You look at your code like this does not look like good code. You yourself will get better at knowing your code's not great and be able to ask others or research better. Like I said, so it's a process. And experience is the big key item. But yeah, you don't necessarily. I don't want to make sure you're understanding that you don't have to rely on others. But as you yourself just become a better developer, you'll notice and be like, you know what I'm writing is not great. It's not clean. I know it isn't, but I'm making it work first. Then I'm going to make it better. I'm going to research how I can make this better.
So it's like any process like that. Even if you want to cook something, the first time you cook a thing, it's everything you're doing is like, I'm reading and making mistakes. And the fifth time you're cooking it, you don't need the recipe anymore. You just
and it looks better. And you got shortcuts now, and you have shortcut tricks and stuff. Yep.
All right, I got it now. Okay, thanks.
Awesome.
Basically, the best saying my boss ever told me was, "You're not Michelangelo. You're not trying to paint the Sistine Chapel the first time around. So, get it to work, and we'll figure it out."
Yes, 100%. And that's again, and I'll even clarify, but that's part of the reason why, as career devs, we try to get you into a job right away as just the full stack developer, not with any sort of mastery. Once you have that job, you're earning on the job experience and industry experience. That's when we tell you, okay, now you can pick a mastery and earn your 6-figure job. You can come back, do AI, machinery, robotics, database analysis, big data management, artificial intelligence, all that stuff. If you now, when you're ready to come back and start getting your mastery, now that you have the industry experience and working with more talented developers, or not really more talented, but just more seasoned developers, and you've grown as a developer yourself, now you're ready to pick a mastery and get your 6-figure job. We got to get you in the industry first. So yeah, you get what David's kind of talking about, that experience with other developers who can critique your code, make you a better developer, and experiences in the industry of how do you be a developer professionally. That's why we tell a lot of students, even those who are earning okay money, like 50,000 already, like, you know, you want to start with a simple developer job, just so you start getting that on the job experience of how to be a developer in the industry. It's key. It's a key stepping stone for any developer, just to get that experience working with real life projects and clients and things like that. I learned the most I ever learned by working on other code that already exists and working on clients' work and getting my code reviewed by others. That's embarrassing sometimes, but it definitely makes you a better developer. So awesome. Great work, Emilio.